Good afternoon. My name is Clint Frantz. I'm with AMD. I'm within the engineering division. I lead a telco engineering team along with a number of other activities. I'm really super excited to talk about and share with you what we're really doing here. You're going to see today, it's the first time we've been able to actually take a telco customer set of requirements and really bring it to fruition. As you look over here, what we really have here is the overall Epic private cloud. When you start looking at this, though, let's talk about what the real problem is. The telco customer historically has run three different infrastructures. They run a telco infrastructure, they run an infrastructure that is the back office, and then they now need to run all the new AI. What's really important is when you run AI, do you really want to run three different infrastructures, or do you actually want to run it all in the telco cloud? The important thing is you really want to consolidate this. It's really a cost play, it's an opportunity play, and the other piece is it's really to understand how do we drive optimization and functionality. Based on those conversations, we have built this demo based on what our customers explicitly have asked us to do. They want us to show that I can have telco performance, I can actually have compliance with all the regulatory demands, I can meet their price, cost, and TCO objectives, and then finally, I can add next generation workloads themselves in there. What you're seeing here in this telco cloud, this was a solution that we built over the last 8 weeks based on one of the large operators here in Europe, and this is their requirement. Show us that you can actually put AI workloads and safely do that on the actual same hardware that you're actually running all of our telco, that I can actually do phone calls safely, but I can also deliver that. So when you start looking at this, and this, what you see here, you're actually seeing three different configurations. Each configuration, in this case, it's a 1P server, 64 core, 2P server, i.e. 128 core, and then 256 core. What we have set up here is we're literally running 4 different workloads. Very traditional UPF, i.e. telco workload. We're running an enterprise firewall, i.e. we can take the back office, the enterprise work, and now we also have AI and ML. The AI in this case is the deep sea. When you actually look at this and you actually take those workloads, you're going from 45, 85, 128 users. You're seeing that scale up. The ability to actually take the same platform and just stack up those capabilities. More importantly, you're seeing a latency of all under 100 milliseconds. You've got all those tokens, in spite of the token increase, you have all those tokens coming in with a consistency of under 100 milliseconds. Just as importantly, when you come here to ML, 6, 21, 51 samples. In other words, that's actually your video stream of 2, 4, and 8 video streams that are coming through that same server. You're seeing down here, the memory, the power, you're going from 440 watts to just under 1,000 watts to just over 1,300 watts. Now, that's really expensive in power. But what's important is you got to go, well, what do I need? When you think about the average telco, this is a telco workload on a small cell site. And we'll cover that in a minute, but more importantly, how do I have the right amount of compute throughout the week so that I actually meet their needs? Jitter, in that case, is literally down in the 1.1 to 0.13 milliseconds, so it's incredibly tight. So not only do you get the throughput, but you get the quality of the throughput, which is just as important. And then finally, in the UPF, you're going from 5 million packets a second. Obviously, every call goes through with packets, up to 25 million. And again, full scalability. Look at the drop packets, 0. That shows you the quality of this solution. All of this has been put together in the last 6 weeks to show that I can concurrently run all 4 of those workloads that they need to run in their own private cloud. Now, let's continue with that. So now we see this lovely, nice $94,000 number. This really represents a 39% TCO over a 5-year period for a small cell site. So now we can finally go with this. Obviously, we all recognize the diurnals within a telco site. So the up and down in the patterns, the number of users every day. In those 8 days, you can see that 48% of the time, we actually can come over here and look that we can run it in a 64 core. What that means is, over a traditional architecture, I'm saving 68% over running a traditional 2-core, 2-system cluster I can get that down to 48%. As we then complete the 48%, when you actually look at the next portion of the day, right, the portion of the diurnals, you see 35% of the data points actually fall within what we refer to as the 2P. That means that we can meet all of those demands of 1,000 to 1,800 users, and we still can generate a 50% savings. Now, what we don't lose here is redundancy, quality, or capability, because this is now a private cloud. All the other systems work with each other, they support them, full redundancy, but we now can actually optimize and run on one system. When you now look at the 17%, that's the last part of the day. You see a lot of peaks and valleys in here. This last part of the day, you're gonna end up running at a full 256 cores, i.e. you're gonna have to handle all those really high peaks within that day. So we can do that. You can actually see, though, we are spending just over 1,300 watts now, but we're only spending it 17% of the day. The rest of the day, that's actually really optimized. It's really shut down. It's really consuming as little as possible. Let's talk about how we do that in just a minute. So when you talk about that is how do we get there, right? How did we pull all this together? Well, there's three things. It's the performance. If we can't perform, we don't get to play, right? Next one, it's about efficiency. How do we actually drive all of the efficiency? Well, efficiency is TCO, efficiency is power, efficiency is the ability to meet that demand, right? And finally, scalability. How do we actually hit scalability? Well, the scalability is the architecture of the EPYC. The first thing we've done is we've isolated those workloads within this architecture. As you've seen, we've scaled up. We've literally been stacking containers as we keep growing those up. By having them isolated, you're getting the performance you need, you're getting the functionality you need, and you're also getting the consistency. The second thing that we bring is we bring the next generation of the highest performance in the platform. DDR5 memory, we bring in all the PCIe 5. So not only are we the best CPU, but we're the best platform, so you can add other features, other capabilities, other technologies. And now finally, what I wanted to touch on is we're also one of the best open source investments within the industry. I know that we've been part of the Linux Foundation for just over 11 years. We are now one of the big CNCF, or Cloud Native framework, and what that really means is for all Kubernetes, right? As we think about Kubernetes being the next generation of container management, one of the things is over here, you can see we are making huge investments in open source, and that open source is reflected in some of our latest developments. Those developments here, you can see here in the Kubernetes power management. The example in that particular case is the fact that I can tune this CPU with Kubernetes to literally, instead of driving 500 watts, if I realize that I've shed the load over, as you saw over here, I can now drop down the power. And so we're able to show that when your traffic load is low, instead of running at 500 watts per processor, I can now run that at 1 to 2, maybe 300 watts, and now I'm growing, the power consumption is growing with that. Super proud of what we've accomplished. This is a most recent development. We've got this in private preview with 3 different operators, and you'll be seeing us put this out in the open source community in the next 2 to 3 months max. We are continuing to grow in this space. We've got 8 different development areas we're doing in the Kubernetes open source, and we'll continue to develop that because we really believe that EPYC is the right platform, the right service, and also the underlying overall host for all of the future needs. Thank you for your time.